Good day, everyone, and welcome back again to our TLE 10 subject. And for today, our topic is about AM receiver. Let's move forward. The discovery of radio waves is one of the most remarkable and outstanding breakthroughs in the field of science. Scientists had been studying theories, making predictions, and gathering evidences about them since the 1800s. James Maxwell is a Scottish physicist, formulated the equations of electromagnetism to explain electromagnetic waves. These equations greatly influenced modern physics. Electronic magnetic waves are energy waves with both electric and magnetic fields. They travel at the speed of light through matter or empty space without any wires connecting the transmitting and receiving devices. The second one is Mr. Heinrich Hertz, a German physicist, applied the theories of Maxwell and proved the existence of radio waves through a series of experiments. Hertz, the unit of frequency of 1 cycle per second, was named in his honor. Radio waves Radio waves are an example of electromagnetic waves. They exist naturally and can also be made artificially. They are used for wireless transmission of signals over distances for radio, television, telephone, internet, and radar, to mention a few. Other examples of electromagnetic waves include microwave, light, ultraviolet ray, and X-ray. In radio broadcasting in particular, the radio station encodes or puts information in radio waves in two ways: amplitude modulation, or the AM, and frequency modulation, or FM. In AM, encoding is done by varying the amplitude or height of the wave. In FM, encoding is done by varying the frequency or the number of waves that pass per second as measured in the Hertz unit. The transmitter sends out the radio waves in all directions through its antenna. The receiver picks them up through its antenna and decodes the information in them into voice and music that listener hear. Amplitude modulation was the first method used in radio broadcasting in the 1900s. It's still being used today. It is also the simplest form of radio broadcasting. In the United States, AM radio ranges from 500 kilohertz and 1700 kilohertz, or thousands of cycles per second. FM radio ranges from 88 to 108 megahertz, or millions of cycles per second. Now let's talk about radio broadcasting. Radio broadcasting refers to the wireless transmission of audio content to a scattered audience through radio. It comes in several forms as follows. The transmitter and receiver are the two major components of radio communication. Now, let us talk about the components that comprise the process of transmitting and receiving a radio signal. Number one, the radio station. The radio station produces information in the form of music or announcer's voice, whether live or taped. Number two, the oscillators. The oscillators generates a carrier wave or radio wave on which the information will be carried or encoded. Number three, the modulator. The modulator adds the information to the carrier waves to make them AM or FM radio signals. Number four, the radio frequency or the RF amplifier. This one enlarges or strengthens the power of radio signals. Number five, the transmitter. The transmitter emits radio signals from the radio station through its antenna. Number six, the receiver. The receiver intercepts a huge amount of radio signals through its antenna. Number seven, the tuner. The tuner tunes the radio in a specific station through a resonator, also called oscillator, consisting of capacitor and inductor. The tuner selects and filters radio signals from those gathered by the receiver. Not all collected signals will be allowed to enter the tuner at once. Number 8, the mixer converter transistor. It mixes signals received by the antenna and those selected by the tuner. Then it converts them into signals called intermediate frequency, or IF. The typical IF is 455 kilohertz or 455,000 hertz, which is used by all AM radio tuners. Number 9, the IF amplifier or the intermediate frequency amplifier. It works as a gate because it receives only 455 kilohertz. Any frequency that is lower or higher than 455 kilohertz will not be allowed to pass through the radio tuner. There are three IF transformers present in the IF amplifier, which are color-coded yellow, white, and black. Number 11, the detector or demodulator. It is a kind of diode which recovers and decodes the information in the radio signals that have been selected by the tuner. Next, the audio amplifier. It increases the power of selected radio signals and provides sufficient volume to the speaker. Second to the last is the speaker. The speaker turns the radio signals into sound waves which can be heard. And the last is the volume control. It adjusts the potentiometer to increase or decrease the volume of the speaker. And that's it. That concludes our discussion for today about the AM receiver. Hope you've learned something for today.